All right. Hello, everyone, and welcome. I hope everybody's doing okay out there today. I know this is not the ideal way for us to be meeting on our first day of class. It's really nasty. I actually drove my car into a bush this morning, so I'm having a really fun day. But I hope you're all staying warm and safe out there and are ready to talk about some computer science. This is CSE 131/501, and I am Doug Shook. I'm the lead instructor for this course. You probably saw me in the labs last week if you were able to make it to the lab session. And as I explained at that time, I'm certainly not the only person involved in teaching this course. There are lots of people helping me out. This is a big class. You can see we've got it's like 130 people now, plus a whole other section happening after this one with at least that many students. So big class. We've got some other instructors and lots and lots of TAs. I believe our at least one. Oh yeah, both of our head TAs are here with us. So yeah, Claire, Vicky, if you'd like to say hello to everybody real quick.
Hello, everyone. I'm Claire. I'm one of the co-head TAs. Vicky, say hi.
Vicky. Hello. I'm the other head TA. We have like 70 TAs who all kind of look like students, but you'll get to know at least a few of them throughout the semester.
Yeah, awesome. Thank you. And so just to kind of give you an idea of their role, they're basically overseeing everything TA related. Obviously, I'm involved as well, but Vicky and Claire do a great job of managing where the TAs are supposed to be and when, and making sure they're doing their jobs. So it's very likely I'll run into one of them at some point over the course of the semester, although I hope I also get a chance to speak with you all this semester too. And many of you met Brian and Athena in the labs the other day. So lots of people helping this course, make this course happen. I want to start out with a very important message. Make sure that everybody knows right away that you are welcome here. And I mean this statement in a few different ways, right? So I mean this statement, one, from a purely computer science perspective. This is an intro course, right? This is an introductory computer science course. This course is intended for people who have never written a line of code before in their entire lives. I know that may not apply to everybody who's listening to me talk right now. Some people do come into this class with prior coding experience, and that's fine too. I think that, as time goes on, more and more people are being exposed to coding earlier, and that's great. This course serves as an introduction to computer science, not just in the general sense, but also to kind of how we do things here at WashU. So I think even if you have done some coding before, this course will give you a taste of how we like to do things in the computer science department here at WashU. The only case where I might recommend you not being here is if, especially if you took the AP CS test and did well on it, you actually can test out of this course. If you feel that this course is, so easy as to potentially be, not worth your time, like you just aren't getting a lot out of it, I would not encourage you to stay in this course either. That's sort of a personal decision, though, one that I'm happy to talk to you about if you feel like it might apply to you. There is a placement exam that you could take. So if you didn't take the AP exam to test out, you can take the placement exam, possibly test out of this course if you would like to. But nobody's going to force you to do that. I might ask you to consider it if I think that if it's a possibility for you. But everybody who wants to take this course is welcome to take this course. This course is meant for everybody, but especially intended for brand new coders who have never written any code before. So I want to make that clear right off the bat. I know that a lot of people can be intimidated by learning how to code. Computers can be kind of scary, especially when you see all the new stuff we're about to teach you this semester. But I promise you, if you want to learn it, you can learn it. Lots of students have, and you can too. So the other thing that I want to make clear is that everybody's welcome here in the sense of whatever social, political backgrounds, diverse backgrounds you may come from. Obviously, or well, maybe not obviously, but I would think you're aware that the tech industry is sort of known for being dominated by cisgender white guys. And last time I checked, I also fit into that category. I'm very aware of my privilege to be, standing up in front of you today as the professor of this course, as somebody, teaching computer science to you. But I also take it very seriously to make sure that everybody does feel welcome here, and that we include everyone who wants to learn computer science. So if at any time you don't feel welcome in this course, for whatever reason, whether it's related to code or otherwise, I do hope that you come and talk to me about it, so that we can figure out whatever problems you're having. Make sure that anybody who wants to learn computer science at WashU has the ability to do so. It's very important to me to make sure that that happens. So on to a little bit more about myself. Just kind of want to give you a little bit of a personal background about me and how I got into computer science. One of the things that I really like learning about all of you as I teach this course is why you're learning computer science. And there's tons and tons and tons of reasons as to why people learn computer science. And some of which we may talk about later today. But I got into computers the way that many, kids got into computers, which is through video games. And so this is actually one of the first games I remember playing on the computer, as well as one of my first ever introductions to coding, to programming. This is a game called QBasic Gorillas. And you're one of two gorillas situated on top of a skyscraper. This is randomly generated, by the way. You get a different, set of buildings every time you play the game. And the object of the game is to type in an angle and a velocity, the units of which are, somewhat unclear. But you type in an angle and a velocity, and then it shoots off an exploding banana in the direction of the other gorilla. And wherever that banana lands, it explodes, and hopefully it lands on your opponent. But if it doesn't, it starts taking chunks out of the buildings, and then your opponent gets a turn to throw an exploding banana at you until one of the two gorillas blows up. But one of the great things about this game was not only that the game itself, but it gave you all the code. You actually got to see all of the code. In fact, you can still go find all of the code today. I'm sure it's accessible. It came in a language called BASIC. But that was the first time that I actually remember being able to control things on the computer in a really significant way. Even things like, how big the exploding bananas would be, and where the gorillas would go, and things like that were all able to be manipulated just by kind of looking at the code and trying to figure out how it worked. And so that was when I was a small child. But my interest in games and computers continues to this day. So these days I play a lot more modern games, and I'm actually into hacking. So this is an example of a map that was generated by a program that I wrote. I'm a big fan of Zelda 2, which is the second game in the Legend of Zelda series. Came out on the NES in 1989, I believe. So what? No, my mic is on. Yeah, people can hear me. Somebody's asking if my mic is on. I hope I haven't been just talking this whole time to no one. Okay, great. Thank you. Yeah, so yeah, I switched over to Zelda and got involved in speed running and randomizers. So what you're actually looking at is a hack that I made that takes a video game, an NES game, and hacks it and makes a brand new map that you can play. Because I got tired of playing I got into speed running. I actually held the world record for Zelda 2 briefly in speed running, but I got tired of playing the same map over and over again. So I used the randomizer as a way to make new versions of the game that I could play. It's still one of my all-time favorites. I still play it very frequently. So that's how I got into coding. I know a lot of other people have a taste for video games. So if that's, happens to be you, I'd love to chat with you about it sometime. I also use coding for lots of other things. It's not just video games. I use it for my job, for education. I care a lot about studying or helping people study coding, rather is a better way to say it. But as we go through this semester, I want to hear from you. I want to hear about why you're here. A lot of people are here because they are interested in doing research. That's great. I would love to hear about the research projects you're involved with. I might even love to get involved with your research project. It's not unusual for students to ask for help with coding projects that they're working on outside of class. That's something that, I'd love to chat with you about sometime. So, maybe you're interested in developing apps, cool app ideas, either on the computer or on your phone. I would love to talk to you about that. I've made some Android apps myself, more of an Android guy than an iPhone guy, so I don't know a whole lot about iPhone development, but would still be happy to talk to you about application development as well. So all things that I love to hear about. That's actually one of my favorite things about teaching this class is hearing all the different reasons that people like to get into computer science. Let's get into the more practical stuff, though. One of the main things about today is one of the main things we care about today is how this class works. So this class follows a certain rhythm. It's a little bit different than probably some of the other classes you're used to taking, but I think after a few weeks you'll get used to the way that we do things. Mondays, which is today, right? That's where we are right now. These are lecture days. So I didn't ask you to do anything ahead of class today. It's the very first day. But from now on, I'm actually hoping that you'll review the material ahead of time. We'll talk about that a little bit later on as I show you some of the course materials. But I'm not suggesting that you spend hours and hours. It's not in the sense that there's prep work. You're not graded on whether you review the material or do any course readings. I just think that it's in your best interest to at least have some idea of what we're going to be talking about before coming to class. I think it will, give you the opportunity to ask better questions. I think it will give you the opportunity to formulate some of those ideas in your brain ahead of time, as opposed to kind of in class on the fly. So, but regardless, when you come into class on Monday, I'm going to be here. I'm going to be ready to answer any questions that you have. And then also I'll be working through the exercises, the same exact exercises that I'm asking you to do. So that's another reason why I ask you to do them ahead of time. There's a very big difference between watching me do something on the computer and actually doing it yourself. So, it's very possible that you try a problem and get stuck. I think likely even that you get stuck. But I think even that attempt, even that trying is such a valuable learning experience that I really want you to try and do that first before coming to class and watching me do it on the computer. And even then, after watching me do it on the computer, I hope that you also do it, because that act of actually doing it is really the most valuable part of this entire class. That's the practice. That's the good stuff. So Mondays are when we will introduce a new topic, go through examples, answer any questions that you have from the course materials. I'll show you where the course materials can be found a little bit later on. And then on Wednesdays and Thursdays, depending on which section you're signed up for, that's going to be studio day. So studio day is when we ask you to do an in-class activity with your peers. So you kind of got a little taste of this last week when you came into class. These sessions are graded. So we do grade these sessions. However, they're not graded on whether you get it right or wrong, or even whether you finish. It's mostly graded on attendance, whether you show up and work on the problem for the duration of class. So the problems are intended to be finishable in 80 minutes or so, especially if you have come to lecture and done some practice ahead of time. If you show up to studio and you haven't looked at the material much, you're going to have a hard time, right? That is not intended to be the introduction to the material. That is intended to be a problem for you to work on after you've already done a little bit of work on the topic for that week. It's a bit of a bigger problem, not intended to be tackled by yourself either, meant to be done with your peers so that you can talk and work together. And then I also post a review video every week, so I actually will walk through the studio solution. That way, whether you finish it or not, you actually see a full solution to the problem every week. After the studio is done, that's when we turn you loose on homework. So every week, every module will have a homework assignment associated with it. It's going to be due the following week. So if you did studio on Wednesday, then the homework assignment will be due the following Wednesday, one week from that date. You'll also be doing another studio on that day for the next module. So they kind of overlap a little bit in that way. But I think that you'll find once you do this a few times, you'll get used to the rhythm. This idea of showing up to class, turning in your assignment, and then beginning the next studio assignment. You can also turn in your assignments during office hours. A lot of students find that this is a great way to, not have to worry about it during studio time and just focus on your studio. If you want to turn it in early, or should you need to turn it in late, we'll talk about that as well. And then finally, the last part of every module is a very brief quiz. If you have done the assignment, the quizzes should be very simple and straightforward. Usually do the same day as the assignment, just later on Thursdays. Every Thursday, just to kind of check your understanding. I know that's kind of a lot to throw at you. Again, it'll take a few laps through this to kind of get used to it. I'm going to go back actually through all this again and talk about exceptions to these rules, such as like what happens if I can't make it to class, or what happens if I don't get an assignment turned in on time. I have answers to those questions, but this is the path. This is the goal that we have. This is what we hope will happen. If everything runs smoothly for you, which for many of you it will, right? For many of you, you'll have a very smooth experience. You'll get used to this rhythm of showing up to studio, showing up to lecture, turning in your assignments. All righty. I'm about to switch over to Canvas and give you a little bit of a tour of the other stuff that's on there. Before I do though, any questions about kind of the flow of class? Feel free to hop in chat. Your mics will be muted. There's too many people for that, but feel free to pop any questions you have in chat. I'll get to them as I go through. Was last week's work due already, or is it due this week? Well, I'll be able to answer that for you pretty shortly here as we go through Canvas. So let me work through Canvas. We'll answer that question in just a moment. This is what your Canvas probably mostly looks like, depending on what section you're registered for. Some of the dates and things might look a little bit different. But I wanted to start by pointing your attention to the calendar. Everything for this course has already been mapped out for the entire semester. So all of the assignment due dates have already been mapped out for the entire semester. All of the quiz due dates, right? All of that stuff's already been mapped out for the entire semester. All of the exams, all of that's already known. So if you want to know when something's happening in this class, all you have to do is look at the calendar and you can see it. So the important things to know, you can see the assignments when they're due. Again, check your version of Canvas. This is going to look a little bit different depending on what section you're registered for, the due dates and times, but they will be accurate for whatever section you're registered for. And then the exams, pay special note to those. Those are going to be in the evenings. So the exams are a little bit different. We'll talk more about what the exams look like as they get a little bit closer. You'll see that the first exam is not until about a month away, but we'll have a review session ahead of time. So all of the due dates and everything is all known. The only thing that we've actually had due so far is Studio 0. And as a reminder, Studio 0 and Assignment 0 are just warm-ups. They don't count for credit. They're practice. We probably won't even post grades for them. So, well, we may post grades for Assignment 0. We almost definitely will not post grades for Studio 0. It does not count. We did not take attendance last week for the first week of class. But we will start counting stuff for real this week. So on Wednesday or Thursday, depending on the day, we will take attendance in class. That is something that will happen. At the end of class, the TAs will go around and they'll talk to all of the groups and check in with you and take attendance and give you credit for studio on the spot. Same thing for the assignments. Yep. So let's go back and take a look at some course policies. So far, I've kind of been talking about what happens if everything goes well. We need to have a conversation though about, what happens when things don't always go smoothly. Although I guess before we get to that, we can take a look at the grading breakdown. We've got the weekly assignments that I mentioned, the studios that I mentioned, those are attendance based. So that's just based on whether you should come to class and participate for the 80 minutes every Wednesday or Thursday. The quizzes, which are all online through Canvas, and then 3 exams. There's actually 4 exams. So we'll talk about that in a little bit. But let's go through each category and talk about what happens if things don't go well. So for assignments are going to be due every week. If you have to submit something late for some reason, you're going to have to use what are called late coupons. So everybody is going to be given 14 late coupons. And each late coupon is worth 1 day of extra time on an assignment. So if your class is on Wednesday, but you didn't get the assignment done and you can't get it finished until, office hours on Thursday night, that's 1 extra day from Wednesday to Thursday. That would be 1 late coupon. You can use up to a maximum of 7 late coupons per assignment. So you can turn in an assignment up to 1 week late and still get credit for it. There's no penalty. You don't get any points taken off or anything. All you lose are the late coupons, right? Yeah, and you don't have to do anything. You don't have to ask to use the late coupons. The system takes care of it automatically when you turn the assignment in. That'll make a lot more sense when I show you how assignments are submitted here in just a little bit. I'm going to walk through that process with you. You can also turn in assignments early. In fact, we encourage you to do so if that's something you're able to do, right? And also, I want to make it clear that while I certainly hope that 14 late coupons gives you enough flexibility to turn assignments in on time, I also know that things happen. Sometimes very serious things can happen that can cause you to lose a lot of late coupons in a hurry. If you ever find yourself out of late coupons, please come talk to me, right? I don't want lateness to be a reason why you do poorly in this class. I will be flexible. The TAs will not be. You will not be able to get things past the TAs if you do not have late coupons available to use. But I can be flexible, and I will be flexible if you come talk to me. So use your late coupons, but if you ever run out, come check, and we'll talk about it. Studios, if you miss a studio, there's no makeups. You have to be there. So you go out of town, sorry, you have to be there. I don't care what the reason is, right? If you're sick, I'm sorry, got to be there to get the credit. If you are on a team or something like that, traveling for WashU, same story, have to be there to get the credit. So if you're traveling out of town for whatever reason, can't make it to class, you won't get credit for that day. However, you're allowed to miss 2 studios before it starts counting against you. There are 10 studios total. So that means you have to attend 8 out of 10 to get the full studio credit. And also, it's honestly the same story as with the late coupons. If you miss 2 studios and it looks like you have to miss a 3rd or a 4th for some reason, come talk to me, right? Yes, the policy is no makeups for any reason. Yes, the policy is you can only miss 2, but I'm a reasonable person. Come tell me what your situation is. The course policies work for most people, but they won't work for everybody. So, if the course policies are letting you down, if life is giving you trouble, come talk to me. We'll figure something out. Quizzes are worth such a small part of your grade, 2%, that there's no makeups, no nothing on that one. If you email me about missing a quiz, I'm going to be like, sorry, quizzes are worth like a tiny fraction of your final grade in the course. Just do it next time, so no makeups or anything like that. Although now is a good time to mention, because nobody has called me on it yet. What do these add up to? 36 plus 10 plus 2 plus 54 is actually 102. Yeah, somebody noticed. That's not a mistake. That is very much intentional. That is more flexibility for you. I don't do extra credit. There is no extra credit. people will ask me for extra credit anyway, and I will say, no, I don't do extra credit. But instead, you do have a little bit of flexibility. You got some 2% of wiggle room, right? Look at that. That means you don't have to do a quiz all semester if you don't want to, and you can still get 100%. I don't think that's a great way to use it personally, but you could. That's half an assignment. Okay. Also not a great way to use it, but it's there. You have that flexibility. You have that wiggle room baked into the course policies. Exams. So again, it's kind of a similar story. There's no makeups, right? It's a repeat. It's kind of a repeat thing. And I'll explain the reason for that. I mean, it might seem like a very strict policy, but again, this is a big course. I liken it to a train, right? This train is leaving the station right now, and it's not stopping until the end of the semester. I understand that life's gonna knock you off the train sometimes if you get sick or something, and we'll help you get back on whenever you're ready. But we're not stopping, right? The exams are gonna happen, the quizzes are gonna happen, the studios are gonna happen. We've got all of this stuff planned out with plenty of warning. The exams themselves were actually advertised in the course description. So no, there's no makeups for any of that stuff. I see people asking about early exams. Same story. We actually have everybody take the exams at the exact same time. That's an academic integrity issue. So yes, you can be at the exams when the exams are given to everybody else, or you aren't taking that exam, but there is still flexibility. We give you a drop. So if you can't attend an exam for any reason, that'll be your drop. If you do attend all of the exams and you just have a bad exam for some reason, okay, we'll drop your lowest exam grade. So there's four exams, but only 3 of them count towards your final grade. Your lowest exam grade will be dropped. And that includes the final exam. So what ends up happening for a lot of students is that they'll take exams 1, 2, and 3 and decide that they don't need to take the final. They're just going to drop that one. That is totally okay with me. I do not have a problem with that at all. The exam drop is going to be applied regardless of, what exams you show up to or not. However, as it was with the studios and as it was with the late coupons, if you ever find yourself in a situation where you are unable to attend the exams for some reason, please come talk to me, right? I am going to expect you to use your drop. So that's the first thing I'm going to say is, okay, you can't come to an exam, that's your drop. But if you have to miss another exam for some reason, I hope that doesn't happen, but it does. To some people, it does happen sometimes. Come talk to me. I can't promise anything, but I will listen and I will absolutely try to do whatever I can to make it work for you. There are other things that I can do, but I can't do that if you don't come talk to me. So I hope you do. I hope you come talk to me. All right. Letter grades. This is graded on a straight scale. So no curves. I actually personally don't like curving anything, so I will not be curving things. I mean, I suppose if I absolutely thought I had to, I would, but that's never happened. So, probably not going to be a curve. These are the grades that'll be applied. If you're taking the class pass fail, a passing grade is anything above a 70. So 70 or up is passing. Anything below 70 will be given as a failing grade. We'll talk about academic integrity in just a little bit. So I'm going to leave this one on hold for now. But yeah, let me just make sure I didn't miss any questions in chat. See some stuff asking about office hours. That's the next place on my list, actually, to go to. How to get help. Office hours. So our TAs have office hours. Office hours for the TAs are going to start on January 28th. The first homework assignment is not due until January 31st. So office hours start here. First homework assignment's not due until here. That should be plenty of time, right? For the first homework assignment, for you to get help on the first homework assignment. If you need help prior to that, or even if you need help after that, you can also come talk to me. So if you want to talk to me, there's a link here to schedule an appointment with me, right? So I have the ability to meet with you. If you email me to set up an appointment, I'm just going to send you to this link. So, You're welcome to use this link for whatever you'd like. I don't know why the site's being so slow to load. Maybe it's not working at the moment. I'm not so sure. Oh, there it goes. Yeah, it just took a second. So yeah, this is the way to set up an appointment with me. I have my availability on here. I keep it up to date. I try to do a good job of keeping this up to date. So the times that you see on here for me to meet are the times that I have. I don't have, times outside of this. But you are welcome to come to me for questions. You're welcome to come to me for help on assignments. If you need to submit an assignment, you're also welcome to come to me. Anything related to this class, anything related to computer science. Maybe you have questions about other courses in the computer science department. I'd be happy to talk to you about that. Maybe you've got a personal coding project you're working on. I'd be happy to talk to you about that. I really want to talk to you about anything. So please don't hesitate to use this. A lot of students will go to the TAs. They prefer to go to TA office hours. I completely understand. But one thing that I hear a lot is somebody will go to TA office hours and the TAs aren't able to help you for whatever reason. That's not, outside the realm of possibility. Our TAs are students like you. They vary in terms of their experience. Some of them have just taken this course, right? Whereas others have been around for a few years and know the material backwards and forwards, right? So don't be surprised if you get told by a TA you don't know an answer. That doesn't mean that you need to give up or that the problem is unsolvable. Come talk to me. One thing that I don't like to hear is the students say they asked a TA and TAs couldn't help and then they just give up. No. Come talk to me. I guarantee you I'll be able to help you with whatever problem you've got related to this class. I promise you. Go to the TAs first if you'd like to, but if they aren't able to help you, please come see me in my office. I'd be happy to help. Oops, I did not mean to close that tab, I don't think. Okay, let's see if I can get that back up real quick. Oh, here we go. This is the tab I wanted. The other way that you can get help outside of class is by using the course message board. So we have a course message board called Piazza. There's a link to it right here on Canvas that you can click on. In fact, I would like for all of you to go do that right now. Go click on that Piazza link, which is again opening a bit slowly for me for some reason. Maybe because I'm on Zoom eating up all my internet. It'll ask you to sign up and register for a Piazza account, which should only take a moment. Oh, well, I clearly missed that question. I did email it out though. Not sure. Hopefully you're getting emails from me. Not sure why you wouldn't get emails from me, but yeah. If you want to ask questions outside of class time, outside of office hours time, this is the place to do it. All of the TAs of the class are on here. So as Vicky said, we have about 70 people. You're welcome to email me. I don't mind if you email me questions about the class, but I just want you to keep in mind that I'm one person. And this message board is seen by many, 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 many people. So you are much, much, much more likely to get a quick answer if you post here. I do realize, though, that there are some questions that maybe you don't feel comfortable asking TAs that you only want to ask me about, in which case, please send me an email or make a private post. It's also possible to make a private post on Piazza that is only visible to me. It really does not matter to me how you want to contact me. I guess if you asked me, I would actually prefer you come speak to me in person, especially if it's about something important. But if you think it's email worthy, please send me an email. I'm not going to get upset if you email me, if you post a private message on Piazza, whatever the case may be. I want to be as available to you as I possibly can be. So Piazza is great if you have quick coding questions. There's lots of TAs on here who'd be happy to talk to you about coding stuff. I'm also happy to talk to you about coding stuff. But yeah. All right. The other thing that I want to talk about before we switch and do some coding, hopefully today, is how to submit assignments. And we also have academic integrity left on our list as well. Let's talk about how to submit assignments. Everything in this class that you turn in, well, the assignments specifically, but also studios, right, to a degree, must be demonstrated to a TA. or an instructor. So when you come into class on Wednesday or Thursday, the first thing that's going to happen is that we're actually going to ask you if you wish to submit assignment 0, which is due on Wednesday or Thursday. But also remember, it's just practice. It's just warm up. If you wish to submit assignment 0 during the first 15 minutes of class, we're going to ask you to go to the help website. Here's the address here, woostel-cse.help. We'll have it all in the labs on the whiteboards and stuff too. When you get to class, you'll go to this website. You'll click this button to log in with your GitHub account. It might ask you to pull up the GitHub page and ask you to type in and stuff. Your page will look a little bit different than mine since I'm the professor. But yeah, there'll be a thing here for our class. And then there'll be a thing here for your lab section. So, here's one for Wednesday at 1 o'clock. Obviously, it's not Wednesday at 1 o'clock. But if you click on that, you'll see that we've got lists. If you want to turn in an assignment, you'll hop in on the demo list. And what that means is that you're waiting to show your work to a TA. So what does it mean to show your work to a TA? Well, let's take a look at the rubric for assignment 0. So assignment 0, which is due on Wednesday or Thursday, on Canvas down here at the bottom, this is the rubric. When you sign up to demo assignment 0 in class, in the labs, you'll wait your turn. One of the TAs will eventually call your name, and it'll actually pop up a little box on your screen that says which TA is helping you. So the TA will call your name, you'll raise your hand, they'll come over and introduce themselves and say, hi, how you doing? And then they'll start running through the rubric. So they'll say, hey, do you have Eclipse up and running? And you'll be like, yeah, here it is. And then they'll ask you if the assignment's correct. So assignment 0, I believe, asks you to use the robot to draw a little picture on the screen. So you'll show the picture to the TA and they'll check that off. They'll ask if you got everything pushed to GitHub. They'll ask if you got all this stuff. So they'll just go right down the rubric. They'll check it off right in front of you as you show them all the pieces. So there's no surprises. You'll know exactly what questions they're going to ask of you during the demonstration ahead of time. In fact, I would go so far as to say you should prepare for this, right? You should not hop on the demo list until you have looked at this and can say, all right, I know you're going to ask me this. Here's what I'm going to say. I know you're going to ask me this. Here's what I'm going to say. Right? Do this ahead of time. Make sure you are ready. They're not going to go off this script though. This is exactly what you're going to be asked. This is exactly what we're going to be looking for. Once they are done, that grade is automatically in the grade book. So as soon as the TA says, great job, you got all the points, or if they take points off, they'll tell you what points they took off and why. They have the ability to do that, right? But once it's done, that grade is in the grade book. It is already there. In fact, I would say you should check it and make sure that there haven't been any mistakes, because it does happen. You can imagine in a class of this size with this many students, there can be mistakes that get made. Please double check. As soon as you demo your work to a TA, you should be able to see your grade in the grade book. You should be able to verify that it's there. And if it's not, then, get that TA back over here and make sure they fix it because they forgot to push a button or something. It happens. Happens more often than you think. So yeah, that's the demo. That's the demo's process. You'll get used to it. Again, at the bottom of every assignment, there is a rubric. So for assignment 1, which is the first assignment that counts, here's the rubric, right? You can see the rubric. Okay. I believe that explains most of the course policy stuff except for academic integrity. Can you demo an assignment more than once if you lose points? Yes, absolutely you can. Yes. You can even use late coupons if you want to. So say you demo an assignment at the due date, and you get points taken off. You can go home, fix it up that night, bring it back the next day, turn it in for a late coupon, get full credit. Is assignment 0 graded? I mean, yes, it is. But if you're asking me if it counts for credit, The answer is check Canvas. All right, let's talk about academic integrity. This is the not fun part. Computer science is hard. I definitely remember struggling a lot in my intro computer science class, which I'll reference a lot as well as we go through lectures. So yeah, it's not easy. You will get stuck. You'll struggle. Struggling is a part of the learning process. So I mean, I think struggling is necessary to really learn important, difficult concepts. Excessive struggling, though, is not. So if you are banging your head up against an assignment for a long, long, long time, that's when it starts to get stressful. Two things start to happen, right? You start to get frustrated with how long it's taking you to solve this problem because you know that it's solvable. You know other people have solved it, right? Why can't I do it? Why is it taking me so long? This is really frustrating, right? It's such a struggle. But then also you're running up against the deadline. Oh, shoot. Not only can I not figure this problem out, but it's due, in a few hours. It's due right now. And I'm not done yet. What am I going to do? What am I going to do? So, that sucks. It's a crappy situation. I hope it doesn't happen to you, but the fact is it's going to happen to some people, right? This is college. That's a thing that happens to some people. I'm here to tell you right now that I really hope if you find yourself in that situation that you do the difficult thing and just take the L, right? Submit what you have. We take partial credit. If you really have nothing, take the zero. Take the zero. Honestly, it's not fun. I'm not going to say you should be happy about it. I'm not going to say you should like it, but it's the right thing to do. It is absolutely the right thing to do. Consider the alternative, which is to, try and get around the rules. Again, I think stress plays a big part of this. Nobody comes into a class saying, I want to cheat. Nobody comes into a class saying, yeah, I'm just going to coast through this class the whole semester. At least I don't think people are saying that. I hope people at WashU are not saying that. That's not the, impression that I have of students that come here. They do it because things get hard. Things get stressful. The class maybe isn't exactly what they thought it was. All very understandable reasons, but unfortunately just not an excuse, right, to commit academic integrity. If you have a hard time in this class and you don't get an assignment turned in, you get a zero, for whatever reason, the assignment was hard, life was hard, something just wasn't going well, come talk to me. I will give you all the sympathy in the world. I will work with you. I will try to help you learn the material. I will bend over backwards to try and find ways to, get you back on track. That's my job. That's what I want to do. That's what I come into my office every day, hoping to help students with. If you, buckle the other way to the stress, then unfortunately, I'm going to have to do my job as well and report that to the school. So I do not take academic integrity lightly. I report cases to the school every semester. Last semester was not an exception. You know, just because it's possible to get code from a friend or get ChatGPT to do it for you doesn't mean that that's the right thing to do. I will be much more impressed if you take accountability for your situation and take the partial credit or the no credit and come talk to me than if you try to cheat and get away with it. That's not going to earn any respect from me whatsoever. I will understand it and I'll be sympathetic to you still, but it's just not the right way to solve the problem. And I'll submit it to the school. We want to help you. We want to make this a fun experience for you. We don't want to have to crack down on cheating and stuff like that, but it is important and we're not going to turn a blind eye to it. So please review the policies on Canvas regarding academic integrity. The things that I see the most often are students looking at each other's screens. I know it seems innocuous. Nobody does that with the intent of copying, but I actually consider it to be over the line. It's not necessarily malicious, right? You're like, haha, I'm going to look at his code and like start typing stuff. but you're probably just like curious, right? You want to see how your friend did it, or something like that. But it's not the right way to approach these problems. In studio, when we're asking you to work in groups, that is totally fine. In office hours, or if you're working on an assignment or something like that, if I see you looking at somebody else's screen, you'll definitely get a verbal warning from me, right? And if it keeps happening, that's an academic integrity violation. I know it's not a deceitful one or even necessarily an intentional one, but it's important to make sure that you're keeping your eyes on your own work, taking it seriously. Yeah, I would actually say that's by far the biggest kind of academic integrity issues that I see. I also see students acting like these are group assignments. They are not group assignments. They are individual assignments. Can you talk to other students about the assignments in this class? Yeah, absolutely. Can you look up stuff online about what we talk about in this class? Yes, absolutely. There's a very big difference between Googling Java for loops versus Googling, CSE131 assignment 3, right? Like those are going to lead you in two very different directions. One of those I would say is very okay and is going to give you a lot of great resources on how to learn how to code and hopefully make progress on whatever assignment you're stuck on. Whereas the other is just going to give you a direct shortcut to the answer. Like, I'm not an idiot. I know that solutions are probably available to much, if not all of this stuff, if you dig hard enough. Whether online or through your friends. Like, I'm not an idiot. We're asking you to be honest. We're asking you to do the work. That's what you're here for, right? That's what you're here for. In fact, it leads well to my next point, how to do well in this course. Practice, right? Write the code. Another version of this question that I get asked a lot when come exam time is, how do I study for the exams? And my answer is always, write as much code as possible. Have you done the exercises? Have you finished the studios? I provide all of these practice problems, all of these examples. Have you written every single one of them? Because every single one of those is a chance for you to practice. And practice is by far the most valuable thing that you can do in this class. It's by far the best way to learn how to code, how to write code, how to understand code, how to get better at writing code. Please write code. Please do the exercises. When I ask you to look at the stuff before coming to class, I hope you actually try them. When you go through the exercises, when you go through the course content, as I'm about to do with you for the first section, if it asks you to stop and open up a file and write some code in the file, I hope you actually do it. Will I also do it for you in class if you ask me to? Yes, absolutely. That's what I'm here for. I love doing code examples. In fact, I hate slides. You will not, this is the last time you're going to see slides in this class. Hate them. I'm going to be doing all code all the time from now on out. And I hope you will too. I hope you will dive right in and try to write as much code as possible. That is by far my biggest advice to you as to how to do well in this course. Force yourself to write as much code as you possibly can. And if you legitimately do everything else in this, do all the examples, all the exercises, whatever you can get your hands on in this class, and you're just still hungry for more, come talk to me. There's always more stuff we can talk about, always more stuff we can do. But practice, 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 practice. By far the best thing you can do. And then come get help. Please come get help. We have office hours Sunday through Thursday. I am available by appointment. I'm available on Fridays. I think the only day you would not be able to get in-person help for this class is on Saturday. But even then, we're available on Piazza. So I hope that you please take advantage of those resources and come to get help if you need it. Yep, that's what we're all here for. All righty. Seeing some questions in chat, although the last couple look like they've already been answered. So you can always go back and take a peek at the video if you need to review something that I've said here today. Please keep those questions coming. I am done with the syllabus day stuff. So we have about 30 minutes left, half an hour left. I'm going to do some code. We're going to dive right in. and do some programming with the time that we have left today. If you do have any more questions, though, about how this course works, any of the course policies, things like that that I haven't covered, welcome to type them out in chat, or of course send me an email, or hop on Piazza, post a message on there, so that we can clarify things for you if that's what you need. Otherwise, I'm gonna go switch over to Eclipse. And I realized I just realized I need to make the font size bigger real quick. Give me just a moment to do that. There we go. Much better. All right, great. So this is Eclipse, and what I'm going to do for the remaining time is go through some, but not all, of the exercises for Module 1. And so the way that this course works, again, just to kind of give you a refresher of the structure of this class, every module has a rhythm to it. It starts off with some exercises. So this is what I'm doing right now. I'm diving right into the Module 1 exercises. This is going to link you to a chapter from the course website, from the course textbook, right? So if you go through this, you'll actually, starting with this part right here, and there's text for you to read, and then there's also coding exercises. This is what I was talking about, for you to actually open up an Eclipse and go through and work on. So I'm hoping that you do that before class. I'm going to go through some of these now since it's the first day, but I'm not going to have time to go through all of them. So class is not meant to be a comprehensive review of every single thing that is in this. It is meant to be, a review of the topic in general. I'd certainly try to cover as much as I can. And I also care very much about your input. So if there's a particular exercise or an example from here that you really want to see me go through, I hope you tell me that, and I'm happy to do that. I also like to experiment and go off on tangents and all kinds of fun stuff. So it's really, just a time for us to explore and learn as much about coding as we can for 80 minutes every week. And so what I'm going to do now is just kind of start working through this one section at a time and introducing you to the wonderful world of programming, starting with the most simple example of all. This is your basic Java program. So this is a very typical Java program that starts off with a whole bunch of stuff that we're actually going to ask you to ignore for now. So everything from basically here on up, I'm going to ask you to treat as magic words, hocus pocus, alakazam. This is the magic that makes the Java program happen. And we're going to focus on everything that happens here for now. As time goes on, we'll start to expand our focus outwards more and more. But for the first few weeks especially, our view of the program is going to live, kind of in between these two little brackets. And so we're going to type lines of code inside of these brackets. And in here you see one expression, one line of code that is simply going to print out a very basic hello message. It says hi there. See a very good question in chat. How did I get this stuff on my computer? These are the exercises that you were asked to load up during the software installation and setup. So when you came to class on Wednesday or Thursday last week, we asked you to do software installation and setup. Part of that was loading this into Eclipse. So you should have done that at this time. It's called CSE131 Exercises 1, and I just used the little arrows to expand out until I found the Module 1 stuff here. This is all stuff that hopefully you would have gotten through last week. But if you didn't, don't worry, maybe join the class late or something. Do the best you can for now, and then do the software installation setup later. You can always come back and work on these after you get that set up. Still early days. So yeah. I see the word print in here, right? Which is a good indication that that's what this line of code is doing. It's saying it's printing. And then what is it printing? Well, it's printing out whatever is inside of here. So I see parentheses and quotation marks around the message that's being printed out. Okay, well, there's more that we can do to it than that. In fact, computers have lots of different ways of doing the same thing. That's kind of a reoccurring theme. And so here's an example of a program that does stuff a little bit differently. Same kind of idea, but you can see there's 3 statements now. It says hi, and then it says there, and then exclamation point. But you can see that the result gets printed out. It doesn't look the same as the code, right? Looks a little bit different. Well, that's because it really matters which command we're using. There's 2 different commands being used here. One is called print, and one is called println, or print line, right? So the difference between the 2 being that when I use print, it keeps things on the same line, and println, I always get the picture of the old-timey typewriter. It's like moving it back to the beginning of the new line and then starting over again. So when the exclamation point happens, it's going to be at the beginning of the next line, because this command said that this is the end of this line. That's the difference between print and print line. It's up to the programmer, though, to make that decision, right? And in fact, you can change this if you want to have it be all prints and see what the difference would be. Just run the program a second time and you can see, okay, now the exclamation point's up there. What if I make this one println, right? Okay. Hopefully you guessed that it would move the second word down, right? Because now I said that the end of the line is here. I see a question in chat about how the exercises connect to the curriculum. I already answered that, I believe. So please take a look at the prior, you can take a look at the video recording later about the exercises if you need to, or come talk to me sometime after class if you still have questions about it. So yeah, this is what a computer program is, a series of 1 or more statements telling the computer what to do. The computer is not going to interpret our directions or try and figure out what it is that the goal of our program is. It is just going to very faithfully do what it is told to do. The advantage of the computer is that it can do it very quickly. And so I think that's kind of what we'll see as we start to make more and more complicated programs. Of course, we've been dealing with text so far, but we can also do numbers. So if I take a look at something like calculation example, here we're doing some arithmetic. So I see I've got multiplication, I've got division. If you've ever worked with a graphing calculator, something like that, then you've probably seen, familiar expressions to this. I'm running the code by clicking the green circle up here at the top, just like you hopefully would have done for Studio 0 last week. And so you can see, just like you would on a graphing calculator, that if I tell it to print out the result of an arithmetic expression, I don't see the expression, right? I actually see the result. So this is actually the result of the multiplication. This is the result of the division. This is the result of the addition. So we can use computers to perform arithmetic for us. That actually turns out to be very valuable, right? Computing things is one of the main utilities of our computers, because math is hard, or complex rather. Can be. But we have to be careful. Again, computers do not understand our intent. They don't understand why we are writing these programs. They just know that there's programs here with instructions, and they do the instructions exactly as they are given. So when I do a program like this that looks like maybe it's trying to do some computation, it's trying to compute some arithmetic, do some multiplication, when I actually run it, you'll see that, well, okay, that's not actually what happened at all. The computer didn't do anything wrong here. It did exactly what I told it to. It is me as the human being that kind of needs to meet the computer where it's at. So as computer scientists, it's our job to bridge that gap between the human world and the computer world, right? we need to have some understanding of how the computer views the world in order to accomplish our human tasks. So in this particular case, we're introducing the idea of different types of information. We have text information and we have numeric information, right? Stuff, numbers that we wish to do arithmetic and computations with. Anytime we see quotes, that's an indication that we're using the text type. Or in computer science, we would actually say those are called strings. If we want to do arithmetic, as you noticed in the prior example, there are no quotes here. So no quotes. If I'm trying to do math stuff, leave the quotes out of it. Quotes are for if I'm dealing with text. So it's as simple as just coming and altering this line a little bit to actually make it do the computation we were hopefully expecting. And there is the actual value being computed as opposed to just printing it out as a piece of text. Now, computers are also very, 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 very picky about how you tell them these things. So you can't, you can't make mistakes. I mean, you can, but the computer won't run anything if there are mistakes. So what I'm about to show you are some of the simplest types of mistakes that you can make, but they're also very common types of mistakes that people make all the time. I also make these kinds of mistakes all the time. Here you can see an example where I have one quote, but I don't have a matching closing quote. So what does Eclipse do? It's underlines it red and it says it's not, all right, string literal, that sounds weird, is not properly closed by a double quote. Well, okay, that's enough for me to figure out what the problem is. I need to come in here and put in another quote. And now you can see that the red underline is gone and the program will hopefully run properly, which it does. Another example of this, if we take a look at error 2, same idea, but this time with the parenthesis, right? I was missing the parenthesis, so I need the open parenthesis here for the printing. This is the closing parenthesis, right? Another example that I can fix, and then Eclipse will remove that red underline. And then the last example, there's actually 2 errors in this problem. The first one, notice that capitalization matters. We say that it's case sensitive. So this has to be a capital S. Can't be lowercase. Has to be capitalized. Also, we need to have a semicolon at the end of a line. That's like the period at the end of the sentence. That's how it knows that we're done. We have nothing left to say. The expression is over. But again, once we fix up those problems, Eclipse will tell us that the problems are gone and run the program for us. All of those examples of errors that I just went through, those are examples of syntax errors. So those are errors of missing punctuation, usually. Something's out of place, right? Eclipse is really good at picking up syntax errors and showing them to you by underlining them in red and allowing you to fix them. So that's part of our job as programmers, is knowing how to say things properly to the computer so that it can understand what we're trying to do and execute the commands that we're asking for. The tricky part is, again, realizing that computers don't really understand what our program is supposed to be doing. It just sees it as a list of tasks to be done, instructions to be performed. So if I give it an incorrect instruction, it's still going to run it. And it's not going to know that the instruction's bad or producing the incorrect output. The computer has no idea what we're trying to accomplish. And those errors are going to be harder for us to spot, harder for us to fix. They're not going to be underlined in red, but that's our job as programmers. Again, that's sort of our task as programmers, to help make the problem that we're trying to solve fit within the computer's view of the world. So let's move on. You'll notice there's a lot of these examples that I did not do. I'm not going to promise to go through every single example. I do hope that you look at them and practice them as much as you feel is necessary, but I'm going to go ahead and move on and introduce a new topic called variables. So variables are very useful. Variables allow us to apply a label to a value. So values have meaning to us, typically as humans, right? Values have meaning. They represent something a lot of times. So it's nice for us to be able to label them. In order to do so, we have to make a determination as to the type of that value. So earlier we made the distinction between text and numeric. We're actually going to make more of a distinction than that. We're going to have our text values, which we're going to call strings. So anytime you hear the word string, that means some piece of data representing text. And one good way to think about strings, we'll see this more later, is anytime you see the quotes, that means I'm dealing with strings, right? When it comes to numeric values, we're going to break it down, though, even further. If I'm dealing with integer values, then I'm going to use a data type called int. And so here, this line number 7, is declaring a variable. I would say this is a variable declaration. I am creating a variable called score. It doesn't have a value yet. I've just indicated that there is a variable that exists, and it's called score. On the next line, I am performing what's called variable assignment. In fact, the equal sign here is what we call the assignment operator. And the way to interpret these kinds of statements is to read them actually from right to left. I am looking at the value on the right-hand side of the equal sign, and I'm storing it in the variable on the left-hand side of the equal sign. So I'm taking the value of 4 and I'm putting it into a variable called score. We can then, print out the variable called score, which will tell us the value of that variable at the time that it's printed. Okay? This process is so common that we typically don't break it up into 2 parts. We actually do it all as one go. So I would actually prefer to see it look more like this. In fact, this is how you'll see me do it basically here on out. We do the declaration and the variable assignment all in one go. So what's the process for that? First, I declare the type. What is the type of this variable? Then I give the variable a name. We try to pick some name that's descriptive. Equal sign, again, that's the assignment operator, and then the value. What value do I wish for this variable to have? That is how we declare and assign a value to a variable. For non-integer values, we actually have a different type. We call those doubles. So if I have a value that uses a decimal point, I have to declare that variable type as doubles, as a double value. And this matters. Turns out that the operations that we perform, right, the type matters a lot. The fourth and final type that I'm going to introduce to you today is called a Boolean type. So this is probably the most different type out of all of them that we've talked about so far, but also actually kind of simple. Booleans can only have 2 values. They can be true or they can be false, and that's it. That's all. They can only be true or false. To think about why this might be useful, consider that computers see the world in binary, which is 0s and 1s. So in some sense, a Boolean value is representative of a binary, right? True being a 1 and false being a 0. It also turns out that these have a lot of very good uses for us when it comes to programming. We'll see that a lot, especially next week when we talk about some more complex kinds of coding things. But for now, it's enough just to understand that Boolean values exist, and they can only have 2 values, true or false. If I try to put something else here, Eclipse will be mad at me. I'll be like, what? You told me that you're creating a Boolean variable. I can't make that be 7. That's not a proper value. It's not allowed. It would also do the same thing if I came up here and tried to make this be false. It would say, what? You told me you were going to make a double variable here. So that means you're going to give me some number with a decimal in it. I don't understand what this is, right? So Eclipse is trying to help me understand that. Anytime here's an example of creating a string variable down here. So string name equals, and then quotes with the value inside of the quotes. Okay. When it comes to strings, it turns out that strings are a great example of showing why the type matters so much. So consider Question in chat, Boolean is a true or false value. That's it. That's all it can be. It can either be true or it can be false. There's nothing else. Yeah, very simple, but also very complex, it turns out. We'll see more about Boolean values as time goes on. Alrighty. Yeah, so when it comes to variables and things like that, it turns out the type matters a lot. And so let's take a look at an example of why the type matters. Here I'm declaring a variable called score, and I'm assigning it a value of 0. And then I'm doing a print statement. Now here is an interesting statement inside of here. This, inside of the quotes we've talked about, is a string, right? It's a string. This is an addition sign. And this is a variable that has a type of int. So this is a number. So what is, a string plus a number? And the answer to that question requires a knowledge of computers and how they interact with types. This is not addition, right? If I had two numbers, if I had a number plus a number, that would just be your regular old addition that you learned about, whenever, way back when you learned addition, subtraction, all that fun stuff. But types matter. So yes, this is a number, but this side is not. This is a string. Anytime a string is involved with addition, the operation that's being performed is actually called something else. It's called concatenation. And string concatenation, what that does is it takes this value and sort of sticks it together. So whatever value is inside of this variable is going to be tucked inside of the quotes and printed out. So it's going to say the score is 0. So it'll take the value of score and tack it onto the end of this statement, which you can see when I run this program, right? The very first statement says the score is 0. Here I create a variable called price, and then I use string concatenation to tack that onto the end of this string. The price is, and then it's not addition, right? I'm not adding two numbers together. I'm using string concatenation to take this number and tack it on the end of this string. Same thing for Boolean values, right? And also same thing for strings. It turns out I can concatenate two strings together as well. If we take a look at other ways that we can express things, right? Express our variables. Let's take a look at after I declare and assign a variable, I can, of course, use that variable wherever I want. But then what if I want to change that value later? So here you'll notice this statement looks a little bit weird to people the first time that they see it, because this is not math class. This is not an equality, right? If this was math class, this would very clearly be a contradiction. There is no way that score could be equal to score plus 1. That's not possible. But this is not math class. This is computer science class. The equal sign represents a variable assignment, and that means that we should evaluate this statement from right to left. So I'm saying that score plus 1, all right, score is 0, 0 plus 1 is 1. So the value of 1 should be taken and assigned to this variable. So I'm replacing whatever value was in this variable with this new value. It just happens that I'm defining the new value in terms of the old one. And that's okay. That is perfectly acceptable for me to do. I can run this program and you'll see the first time I declare this, I print it out. That's what gives me the 0. I add 1. So I say 0 plus 1. Store that in the variable. Print it out. That gives me 1. All right, 1 plus 1. Store that in my variable. That gives me 2. Just checking into chat here. Boolean cannot be yes or no. It can only be true or false. That's literally it. Not sure how else to say it. Those are the two values it can be. Somebody else asking about system.in. Yes, that does exist. In fact, you have great timing because we've been using print statements to put stuff out into the world. But there is also a way to use the computer to accept things from the outside world in. So let's take a look at that. If I am sitting at the computer and I wish to type some information in to the computer to use it within my program, we can use something called a scanner. So here is the line of code that we use to set up the scanner. You can, again, think of this as sort of magic words. If you need to use a scanner in your program, it's perfectly acceptable to just copy this and use it. That's what I would do. In fact, that is what I did probably to scan. The next line of code here is telling the user what they should type in. So it's saying you should type in your name, right? This is for the human being. This is a prompt to tell the human who is sitting at the computer what kind of information we're looking for. This line of code uses the scanner to accept whatever has been typed in. I'll show you how that works in just a second. It's going to store whatever has been typed in into a variable called name. And then finally, we will print out a short and simple greeting to whatever name was typed in. Let me go ahead and run this program for you and show you how it works. So it says, please enter your name, and it's waiting. At this point in time, I'm actually hanging out here on line 11. It's waiting for me to type in what my name is. So if I type in my name as Doug and then hit enter, it grabbed what I typed, stuck it into this variable called name, and then said hello, and then tacked on my name right afterwards. I know that's what happened because if I run the program again and I type in, somebody else's name, like my daughter Pearl, it'll say hello to my daughter instead of to me, right? So it is reacting based to the user input, the things that I am typing in, as opposed to what is in the code directly. Turns out this is a very, very useful thing and something that we're going to be using a whole heck of a lot. And it can be used for other useful stuff as well. So if I take a look at this example using scanner, you can see that I've declared a couple of variables up here. And I'm using scanner not to read in somebody's name, but now I'm using scanner to read in a number. So I'm asking the user, excuse me, to type in two numbers and then using those numbers to perform some arithmetic, some task, right? So if I run this program, enter the first number 7 and the second number 4, whoops, well, turns out there's an error, right? This error is somewhat intentional. Order of operations matters. If I look at this line of code, let's think about what happens here. This is a string. A string plus a number is going to use string concatenation to generate a new string for me, right? So this is going to say sum is 7. And then this is going to say sum is 7, 4. Well, that's not really what I meant to happen. I wanted that sum to happen. So order of operations. That is totally a thing. Use parentheses to clarify your intent if you have to. Let's try that one more time. There we go. Sum is 11. That is fixed our little issue. But the other thing I was trying to show you is that scanners can be used to pull in values of any type. So in the last example, in the name reader example, I used next line. That's what I used to read in text. Somebody's name, that is a string, that is text. I can use next line with the scanner to read in text. For the sum input program, I was reading in numbers. So I used next int to read in numbers instead of next line to read in text. Also notice though that if I do something weird, right? It says enter the first number, and if I say hello, it says what? Wrong. That doesn't work. That's an error. That's a crash. We made a mistake. So we do have to be careful. Question in chat: what's the difference between a double and a float? Functionally, not a whole lot. You won't see me use floats in this class at all as a data type. But to give you a more concrete answer to your question, doubles are twice as big as floats, so they can represent a lot more numbers than floats can. That's why people don't really use floats anymore. The range of values represented by a double is much larger. Yeah. That's my time. I'm actually out of time. I have to go do this all over again with the next section in 10 minutes. So yes, come to class on Wednesday/Thursday, ready to jump right into Studio One. And please take a look at this prep work between now and then. I did not get to all of it, but the rest is up to you. Let us know what other questions you have, and I'll see you in class. Thanks, everyone. Stay warm, stay safe.